Hello students, welcome you all to the second part of the bridge course, and that is with the topic called as a redox reaction. Before learning the topic that is a redox reaction briefly with respect to the bridge course syllabus, let us revise the previous types of chemical reactions which you have learnt in your lower standard. So the main types of chemical reactions, right? Let us try to understand what is actually a chemical reaction. A chemical reaction is regarded as a process that occurs when matter. What do you mean by matter? Anything that occupies a space and has mass is called as matter, right? And that matter, if it undergoes a change in its composition, and to understand that chemical reactions, one needs to recognize the key types of the reactions. And these reactions may be classified several different ways. Namely, the first one, if you consider, that is synthesis reaction, or it is simply called as combination reactions. The second one is decomposition reactions, which is exactly opposite of combination reactions. And the next one is substitution, in terms of what single replacement reactions. And the next one is precipitation reaction, which are nothing but double replacement reactions. And the lastly, that is with respect to the neutralization reactions, which are nothing but acid base reactions. And the last one is with respect to redox reaction. It is the term which combines both the terminologies, that is reduction as well as oxidation, which is simply termed as a redox reaction. Is it clear, students? So this part you have already learnt in your lower standards. Let us once again recall and then move towards the bridge course topic, redox reaction. Now, in this tabular column, you can see the different types of reaction, the explanation for that type of reaction, the general equation that has been mentioned for that, and a typical example we can see for our understanding. The first one is nothing but called as synthesis reaction, or it is also called as a combination reaction, right? So if you see the explanation, a reaction in which two or more simpler substances, which are nothing but called as elements, combine chemically, not physically, one has to understand, to give a compound, is called combination reaction. The generalized format, you can see that A plus B, formation of AB. A and B are two different elements which on combination gives the product called as AB. And for our understanding, we are having the example, that is formation of water molecule from the elements hydrogen and oxygen. And if you see the second one, that is with respect to the type of a reaction called as decomposition reaction. It is exactly reverse of the combination reaction, right? If you see the explanation, we can just understand that a reaction in which a compound is broken into simpler substances or elements is called decomposition reaction. Right? So in the generalized equation, you can see here AB is a compound which on decomposition gives the individual components of the compound A and B, right? And if you see the example here, water molecule is already present. It undergoes decomposition to produce hydrogen and oxygen. The next one is substitution reaction, or it is also called as a single replacement reaction. The term itself reveals substitution, isn't it? So therefore a reaction in which an atom or a group of atom is replaced by another atom or a group is called as a substitution reaction or a single replacement reaction, right? And if you see the generalized equation here A is an element and here other compound is B and C, right? When reaction takes place from this BC, C is substituted along with A, so this C is accompanied with A and B is eliminated as individual element here, right? Or in the other format you can see that when A is treated with the BC, right, so therefore this B is going to combine with A and C comes out in the form of single element, right? And the typical example, if you see here, very simple examples are mentioned. Zinc is an element. When treated with a hydrochloric acid, so it forms what? Zinc chloride, right? So Zn is going to combine with a chlorine to form what? ZnCl2, and it eliminates what? Hydrogen gas, right? So one has to remember that any substance when treated with an acid, if at all if it is going to liberate a hydrogen, then that element is what? Undergoing a oxidation, that is loss of electrons, right? And the second example you can see here is that chlorine when treated with sodium bromide, we will get here NaCl along with the formation of what? Bromine molecule. In fact, if you see the reaction very clearly, one has to understand that here chlorine Cl2, it is an electronegative element. A more electronegative element is going to displace the least electronegative element. So therefore we are getting here NaCl and then followed by what? Bromine molecule. The next one is precipitation reaction, or it is also called as what? Double replacement reaction, right? A reaction in which a solid compound is formed when solutions of two soluble compounds are mixed. The reaction is called as what? Precipitation reaction or double replacement reaction, right? Here you can see that AB is one compound and CD is another compound. So what happens here is that the D is going to be substituted for B and B is going to substitute for what? D. So therefore we are getting A and D as well as C and B. So therefore it is simply called as what? Double replacement reaction. And the typical example, if you see here, silver nitrate, that is AgNO3. AgNO3 when treated with NaCl, we are getting what? The compound AgCl, that is we have to understand here Ag is going to combine with this Cl and at the same time this Na is going to combine with what? NaNO3. So therefore we are getting silver chloride along with the formation of sodium nitrite. Is it clear, students? And the next one is with respect to neutralization reaction. The word itself indicates neutralized. When we can say it is a neutralization reaction, when an acid is going to combine with a base, it is termed as what? Neutralization reaction. And the typical example we are having here, that is explanation, that is reaction in which an acid reacts with the base to give salt and water. So here we are having an acid Ha and a base BOH. Now one has to understand why in the place of acid it has been mentioned as a Ha, right? So we have already learnt in our previous classes, that is in our lower standards, any substance which gives a H plus ion in aqueous solution, then that substance is called as what? Acid. Similarly, if any substance which gives OH minus ions in aqueous solution, then it is called as what? Base. So therefore in order to accompany these two definition, for acid we have taken here as what? Ha, because on dissociation it produces what? H plus. Similarly for base we have taken here BOH, because on dissociation it produces OH minus. Is it clear, students? So therefore this HA acid and base BOH, when they are going to react, it produces salt Ba and water, that is H2O. And the most simpler example we can see that hydrochloric acid, when treated with sodium hydroxide, it produces salt, sodium chloride and water. Is it clear, students? And the last one, we know that it is nothing but what a redox reaction. See that word redox, it is accompanied by two different terminologies, that is reduction and oxidation. Together it is simply called as what a redox reaction. One has to remember that whenever there is oxidation, there is always what a reduction. That we have to keep in our mind. Is it clear, students? And if you see the explanation, a reaction in which electron transfers occurs is called as what a redox reaction, right? And the general formation of the equation you can see here. First I am going to concentrate on what a oxidation. So B is an element, right? So plus, so here there is a slight change that has to be made, students. So this oxidation has to come here and the term reduction has to come this side. Is it clear? So I'll be writing here oxidation. So you can see that oxidation, OXIDATION, right? So for this oxidation I'm going to write here A, okay? And A is going to be converted as A plus water electron. A species which is losing electrons, you can see that here electrons are coming out from this element A. So therefore a process in which there is a loss of electrons is called as water oxidation, right? And reduction, so let us write water reduction, right? So if I write here a reduction, the element B is here. So this element B is taking those electron and it gets converted into water B minus. So a process in which there is a gain of electrons. So these electrons are gained by this element B. So therefore it carries negative charge. Thus the process is called as water reduction. I repeat it once again, students. A species in which there is a loss of electrons is called as oxidation, and a species in which there is a gain of electrons is called as water reduction. Is it clear, students? So here you can see they have mentioned a simple example. Na, it will be losing electron to form here Na plus electron, that is loss of water electrons, right? And here chlorine is gaining electrons to form 2Cl minus, it is called as gain of water electrons. Well, in fact, students, in this present class we are going to learn the detailed part of water redox reaction and types of water redox reaction. Is it clear, students? So in the study of chemistry, we have come across a number of chemical reactions which are involving addition of oxygen or hydrogen to different substances, right? So in our basic previous classes we have learnt only about addition of oxygen or addition of hydrogen. So therefore addition of oxygen is called as oxidation. Similarly, addition of hydrogen is called reduction. So these are the basic terminologies which we have learnt it, right? Now it has been observed that a category of a particular reactions in which both the types, that is oxidation, that is nothing but addition of oxygen, and reduction, that is addition of hydrogen, occur together and therefore these reactions are called oxidation reduction reactions, or simply these are called as what? Redox reactions. Is it clear, students? So it means that wherever there is oxidation, there must be always what? A reduction. Similarly, wherever there is reduction, there must be what? Oxidation. Is it clear, students? So now we are going to learn what are the different terminologies used for oxidation and that of what? Reduction. So let us understand the different terminologies used for oxidation as well as that of what? Reduction, right? So oxidation is defined as, four terminologies are there. So if addition of oxygen takes place, it is called as oxidation. If addition of electronegative element takes place, then also it is called as oxidation. If there is a removal of hydrogen, then also it is called as oxidation. And similarly, if there is a removal of electropositive element, then also it is called as oxidation. Is it clear, students? And the reverse will be true for that of what? Reduction. So therefore reduction is defined as removal of oxygen is called as reduction, removal of electronegative element is called as reduction, addition of hydrogen is called as what? Reduction, and addition of electropositive element is also called as what? Reduction. Is it clear, students? But one has to remember the modern concept of oxidation and what? Reduction. The modern concept for oxidation is loss of electron. One should remember these terminologies. What is that? Loss of electron is called as oxidation, right? Similarly, here I have to write it as a gain of electron, right? So gain of electron is called as what? Reduction. So these are the two terminologies which are meant with respect to the modern concept of oxidation and reduction. I repeat it once again. What is that? Loss of electron is called as oxidation, and gain of electron is called as what? Reduction. Is it clear, students? Now we are going to learn the examples for each type of this, that is for the first one, second one, third and fourth. Similarly for that of reduction, 1, 2, 3, and that of what? Fourth one. So now with respect to first one, that is addition of oxygen, let us have an example here. So I'll be taking mercuric oxide, that is what? HgO. I'm sorry, 1 minute. Okay, I'll be taking with an example of magnesium, right? Mg, right? Mg, magnesium, when it is accompanied with oxygen, it gets converted into magnesium oxide, that is MgO. Since oxygen is 2 times in the right hand side, so therefore I have to write here 2, and hence magnesium has to be balanced on the left hand side. Is it clear, students? So magnesium when combines with the oxygen, it forms what? Magnesium oxide. Thus it is a process of oxidation where we have added oxygen to this what? Magnesium to get what? Magnesium oxide. The second one is with respect to addition of electronegative element, right? So I'll be taking an example of what that is element called as magnesium. We already know that magnesium belongs to S block element, right? So it is having a tendency to lose electron. When it can lose electron? Only when I am going to add an electronegative element. So therefore magnesium when treated with water chlorine, and we know that chlorine is going to take electron, so therefore I can write the product as water MgCl2. Is it clear, students? So whenever we are going to add an electronegative element, then also the process is called as what? Oxidation. One has to remember that an electronegative element should be added to an electropositive element, then only it is called as what? Oxidation reaction. And moreover, if you see in this formula, that is what? MgCl2. Okay, see carefully here. Magnesium is having the tendency to to lose electron, so therefore I can write here water plus 2, right? And Cl is having a tendency to gain electron, so therefore I can write here minus 1. So therefore minus 1 into 2, it becomes water minus 2, and here it is plus 2. Both get cancelled and molecule becomes water neutral in nature. And apart from that, we should remember magnesium is having a tendency to lose how many electron? 2 electron. Magnesium forms water Mg2 plus water 2 electrons, isn't it? So therefore after losing 2 electrons, it becomes water a cation, and we know that a cation can combine with an ion. Here what happens? Cl2 molecule is here, it is going to gain how many electrons? 2 electron. So it becomes 2Cl minus. Mg2 plus is going to combine with 2Cl minus to form water MgCl2, right? So the next one is removal of water hydrogen from a substance. So therefore we are having a simple example, that is H2S hydrogen sulfide. When this hydrogen sulfide is treated with chlorine, chlorine will be removing hydrogen from H2S, so therefore we are getting what? HCl plus what? S. Since hydrogen is 2 times and Cl is also 2 times, so therefore we can write on right hand side as what? 2HCl. Hence we call this, even this reaction, as what? Oxidation reaction. And the next one is removal of electropositive element, right? So there is a complex reaction. Let us try to understand in a simpler manner, right? So therefore first let me write it as K4, then followed by FeCN. How many times? 6 times, right? So therefore this is a complex compound, students, right? So this, when treated with water hydrogen peroxide, it gives rise to K3, then followed by Fe, then followed by Cn 6 times, along with the formation of KOH. Now here, students, though this example is quite bit difficult to make you understand, we will try to understand in a systematic manner. Okay, in coming classes you will be learning about these complex compounds also, right? So now this compound, okay, which I'm going to underline here, the name of this compound is called as potassium hexacyanoferrate, and its oxidation state is water 2 here, right? So in the coming days you are going to learn this also, right? Similarly here what happens on the right hand side? So this is called as a potassium hexacyanoferrate, and here the oxidation state of this will be water 3 here, right? So here what happens? In this reactant, here we are having H2 and O2. So here oxygen is how many times? 2 times, but here we are having only 1 oxygen, so therefore I have to write it as 2 times here. So therefore after writing here 2, hydrogen is balanced and even water oxygen is balanced. Here we are having a potassium how many times? 3 times, and here there is one more potassium here, so 3 plus 2, right? So 3 plus 2, it becomes 5. So in order to make it in a systematic manner, what we have to write here is, I'll be writing here 2. By writing here 2, what happens? 2 into 3, it becomes what? 6. And here we are having again 2. So 6 plus 2 is equal to what? 8. So therefore on the left hand side, I will be writing as water 2 times here. By writing here 2, now potassium becomes 2 into 4. 8 times. The reaction is what? Balanced. All we have seen that we have removed an electropositive element, that we have to concentrate here, right? So here potassium was how many times here? 4 times, but in the product side here it is how many times here? 3 times. In fact this is the ratio that has been multiplied here, right? That is different, right? So all we have understood that removal of electropositive element is also called as what? Oxidation. Now in the case of reduction, we have to study with respect to removal of oxygen. So here I am going to take an example of mercuric oxide, HgO. It undergoes elimination of water oxygen to form mercury plus water O2, right? So here what happens, O is how many times here? 2 times. So therefore I have to write here how many times? 2 times. By writing here 2 times, mercury becomes how many times? 2 times. Thus therefore we are going to eliminate this oxygen from this HgO, that is mercuric oxide, and the process is called as reduction. So the next one is with respect to removal of electronegative element. Okay, so I'll be writing here with respect to FeCl3. To this I'm writing here H2, right? So therefore what it forms here is that it forms FeCl2 plus with the formation of water hydrochloric acid, right? So this is 3 times, it is odd number, so therefore I'll be writing here 2. By writing here 2, Fe becomes how many times here? 2 times. So therefore on the right hand side I'll be writing here 2, right? And now we have to see with respect to chlorine, that is 2 into 3, it becomes 6, but here we are having a 2 into 2, that is a 4. So therefore I have to balance this Cl by writing here 2. So altogether here 4 and this 2, it becomes what? 6. Now the chlorine atoms are balanced, and even water hydrogen atom is also water balanced. But what we have seen that here is we have removed this electronegative element, that is a Cl3, to form here as water Cl2. Thus the reaction is called as water reduction reaction. The next one, that is with respect to addition of water hydrogen. A very simple reaction we are going to take here, and that is, you can see with respect to CH2 double bond CH2, it is nothing but called as ethene. Ethene when subjected to reduction, that is by addition of water hydrogen, it gets converted into ethene. Very simple reaction. Is it clear, students? So addition of hydrogen is called as water reduction. So the double bond which is present between these two carbon atoms is converted into single bond between these two carbon atoms. So in the next one, here we are having addition of electropositive element, right students? So therefore let me write the reaction. I'll be making use of HgCl2, right? When this is treated with SnCl2, that is stannous chloride, we are getting here Hg2 and Cl2 along with the formation of stannic tetrachloride, right? So all we have to understand is that in the product side, that is with respect to Hg2 and Cl2, okay, actually this halogen is having an oxidation number of water -1. This we are going to learn in the coming part itself only. So -1 into 2, the whole becomes water -2, right? So this, if I multiply, that is water -1 into 2, it becomes -2, right? So therefore here there is already 2 here with respect to water Hg2, so therefore this becomes what? +1. So +1 into 2, it becomes water +2, and this get cancels and the molecule becomes neutral, right? So therefore in the product side we are having what? HgCl2. it is called as a mercurous chloride. Hg, if it is present in +1 state, it is called as mercurous, whereas the Hg, if it is present in +2 state, it is called as what? Mercuric chloride. So therefore where is mercury chloride in the reaction? In the LHS side we are having what? Mercuric chloride, right? So therefore I have to multiply this LHS by means of what? 2Hg here. If I write here 2Hg, then the Hg on both the side, it is what? Balanced. And at the same time, even the halogen atoms are also water balanced. Can you count the number of halogens? So here 2 into 2, that becomes 4, and again here there are 2, so 4 plus 2, that becomes what? 6, right? And in the product side you can see here there are 2 halogen atoms, so therefore I'll write here 2, and here there are 4 halogen atoms, so 2 plus 4, again it is what? 6. But the major difference is that here it is +1 state, that is Hg is +1 state, state, and but whereas in case of the LHS side it is +2 state, right? So therefore we have added an electropositive element for this Hg2 plus, it is getting converted into Hg+1, and therefore the reaction is called as a reduction reaction. Now we are going to study redox reactions in terms of modern concept, that is electron transfer reaction. And the modern concept of oxidation and reduction, as we have already studied, that is loss of electrons is called oxidation, and gain of electrons is called as water reduction. And whenever there is oxidation, there must be water reduction also. And here we are having an example, that is here we have taken sodium which is present in solid state and chlorine which is present in water gaseous state, right? So therefore we have to write oxidation and reduction. So see here students, sodium after losing electron it is becoming water Na plus. So therefore here I will write above loss of electron, right? And the lost electron is gained by water chlorine, so therefore here I will write gain of water electron. So I will be writing in the below, that is gain of electron, right? But we should remember that Cl in elemental form can accept one electron and get converted into Cl minus, right? But if there are two chlorine, that is a molecule of chlorine, so therefore it has to take two electrons, so that has to be balanced. So here I will write here loss of electrons. Here I will be writing here 2. It means sodium is losing 2 electrons, so I have to write here 2 here, because sodium is a monovalent atom, right? So whenever I write 2, then this becomes as what, 2 times. So all I have to do is, that is by multiplying the equation by writing here 2 Na, you will become as 2 Na plus, and already here there are Cl is 2 times, so it becomes 2 Cl minus. So gain of electrons, again that also will be water 2 itself only. So oxidation and reduction, the number of electrons lost should be equal to the number of electrons water gained. Is it clear students? So I have to write here 2 Cl minus, right? Now these redox reactions can be written in 2 separate steps, right? One involving loss of electrons called as oxidation half reaction, and the other involving gain of electron called as reduction half reaction. Let us have a typical example, that is formation of sodium chloride, right? Formation of sodium chloride. Initially I'll be taking sodium, okay, which is actually a solid substance, right? And if it loses electron, then I can write it as water Na plus plus water electron, and this is in the form of gaseous. Now this process is called as water oxidation half reaction. Right? And the lost electron is taken by chlorine, so therefore I'll be writing here chlorine, but it is present in the form of molecule, that is Cl2, right? So it is accepting electron. So after accepting electron, it becomes what, 2 Cl minus, again it is present in the form of water gaseous, right? But chlorine is having a tendency, one chlorine atom, okay, that is one chlorine atom will take one electron, but since here chlorine molecule is here, so therefore it has to take 2 electron. So what I am going to do here, I'll be writing here 2 electrons, right? So we already know that the total number of electrons lost or gained should be equal to what, each other. So therefore I'll be writing here 2 times with respect to sodium, so therefore it becomes here 2 Na plus, and here it becomes what, 2 electrons. And now this reaction is called reduction half reaction. This reaction is called reduction half reaction. And now I have to add these two equations because I am dealing with what? Formation of what? Sodium chloride, right? So therefore here what happens, these two electrons on left hand side and on right hand side both get cancelled, and remains what? 2 Na, which is solid, accompanied with what? Chlorine, which is gas. Formation of what? 2 Na plus along with what? 2 Cl minus, and that is nothing but NaCl. Is it clear, students? So this is oxidation half reaction and this is reduction half reaction, and the overall reaction is nothing but called as redox reaction. Similarly, we are having another example, that is a formation of magnesium chloride, right? So I'll be writing oxidation half reaction with respect to magnesium, which is a solid. It loses electron since it is a divalent, so therefore I have to write Mg2 plus, and this now it becomes what? Aqueous, along with the formation of water 2 electron, and this process is called as oxidation half reaction, right? And the second part is with respect to reduction half reaction. Chlorine, again it is in the presence of it is in the in terms of what? Gaseous state, and it will be accepting 2 electrons, right? So therefore I'll be writing here what? 2 electrons, and it is getting converted into 2 Cl minus, again it is present in the aqueous form, and now this reaction is called as reduction half reaction, and we have to add these oxidation and reduction half reaction, these 2 electrons and these 2 electrons get cancelled, and remains here is what? Mg, which is present in solid state, plus what? Cl2, it is in the presence of gaseous state, formation of Mg and what? Cl2, it is in the form of solid state. Now is it clear now? So we have to understand how the formation of magnesium chloride takes place by means of oxidation, which is simply called as oxidation half reaction, and other one is water reduction, which is simply called as reduction half reaction. So one has to understand wherever there is oxidation there is always water reduction. Now we are going to study about reducing agent or reductant and oxidizing agent or oxidant. These terminologies are very important. Now let us see that. A substance that can give electron to other substance is called reducing agent, or it is simply called as what? Reductant. Or by other terminologies, a very simple meaning, that is electron donors are called as what? Reducing agent, right? So I want to write a simple example so that you will be understanding very clearly. Sodium is here, right? Na is an S block element. It is having a tendency to lose electron, right? So it becomes Na plus what? Electron. Now this process, that is loss of electron, is called as oxidation, right? The loss of electron is called as oxidation. Here I am saying a substance that can give electron, loss of electron, or it is giving electron, then the process is called as what? Oxidation. Okay, but the substance undergoing oxidation is called reducing agent. That we have to remember. Is it clear, students? A substance which is undergoing loss of electron, the process is called oxidation, right? And the substance is called reducing agent. Is it clear? Now we are having the next terminology, that is with respect to oxidizing agent or oxidant. A substance that can take electron from other substance is called oxidizing agent, or simply called as oxidant. Or in other similar terminology, we are having a simple definition: electron acceptors are oxidizing agent, right? Now I'll write another equation for this oxidizing agent, right? Now we already know that chlorine is electronegative, so it is having a tendency to take electron and it gets converted into what? Cl minus. Cl minus. And now this process is called as what? Reduction. Is it clear, students? Because there is a gain of electron, right? So the substance Cl atom is gaining electron. The process is called as what? Reduction. But the substance gaining electron, that is Cl, is called as what? Oxidizing agent. Is it clear? Now this Cl is gaining electron. Who gave this electron here? Sodium has given the electron because it has lost that electron. You can see here Na plus electron. Now this lost electron is taken by this Cl here. So therefore that I have written here, right? So wherever there is oxidation, there is always water reduction. Now I want to say that this chlorine atom here, it is making this sodium to lose electron and to undergo the process of water oxidation. So I can write it as chlorine is an oxidizing agent, and similarly I can say that sodium is what? The reducing agent, or I can say that sodium is making a chlorine to undergo reduction and behave as oxidizing agent. So whenever I say Cl, I have to take into consideration of Na, and whenever I am expressing Na, I have to take into consideration of what? Cl. Is it clear, students? Both are very, very important terminologies, that is reducing agent and oxidizing agent. Now we are going to learn the concept of oxidation number or oxidation state, right? In fact, one has to remember that, students, unless and until solving different types of examples, then only we can get a clue regarding oxidation number and oxidation state. Yet in this class we are going to solve some of the typical examples. Before that, let us learn the definition and a simple example, right? So oxidation state of an element in a compound, it is always we have to find the oxidation state or oxidation number in a compound, right? And it is the apparent charge, okay, the charge present on an atom of an element in a compound is called as oxidation number, right? So what is the simple definition? So oxidation state of an element in a compound is nothing but the apparent charge that is present on an atom of an element is called oxidation state, right? So we are having one example, that is water with respect to sodium chloride, right? Sodium chloride is having the formula NaCl. The oxidation number of sodium is +1 because Na in NaCl is in the form of water Na plus. So this is represented here. Why it is Na plus? Because sodium is an electropositive element. It is having the tendency to lose electron. After losing electron, the positive charge will be appearing. So therefore this positive charge is nothing but one positive charge. So therefore Na is having an oxidation state of water +1. Similarly, the oxidation state of chlorine is -1. Why? Because chlorine Cl in NaCl is in the form of water Cl minus. Why it is so? Chlorine is an electronegative element. Chlorine, after gaining one electron, it becomes water Cl minus. So this minus is water one negative charge. So therefore we call the oxidation state of chlorine is -1. Everybody understood, students? Now let us learn the rules for assigning oxidation numbers. There are totally 5 rules we have to understand carefully. The first one is the oxidation number of an atom in the elemental state, okay, in the elemental state, or it is simply called as uncombined state. For example, if there is a hydrogen, its oxidation state is 0. If there is what oxygen molecule, its oxidation state is what 0, right? So therefore we have taken it as what 0, right? Then the second one is the oxidation number of an ion is equal to its what the charge carried by that ion. For example, if here we are having what Na plus, the oxidation number of Na in Na plus is +1. Is it clear, students? So in this manner we have to understand the second rule. The third one is the oxidation number of alkali metal in their compound is always +1, because they are having an oxidation state of +1, because they have the tendency to lose only one electron, and only after losing one electron they acquire a nearest noble gas configuration, right? And similarly that of alkaline earth metals, that is group 2 elements, they have the tendency to lose 2 electron. So after losing 2 electron, the charge carried by them is +2. So therefore I am writing here a typical example, Mg, formation of water, Mg2 plus. So this apparent charge present is nothing but 2 plus. So therefore the oxidation state of alkaline earth metal is +2. Right? And the fourth one is the algebraic sum, the very important, of the oxidation numbers of all the atoms present in a molecule of a compound. Present in a molecule of a compound is always taken as 0, right? So this we are going to study with respect to what a typical example, then only you will be understanding. And similarly the last one, that is also the algebraic sum of all the oxidation numbers of all the atoms in the formula of a polyatomic ion is equal to the charge on that water ion. Right? So we are having some examples so that it will be very clear for you people. So here we are going to do calculation of oxidation number of the underlined atom, right? So the first one is CH4, right? So I have to calculate the oxidation number of carbon in CH4, and CH4 is called as methane, right? So hydrogen is always having what oxidation state of a +1, we have to remember, but yet there are exceptions, right? So what I can do is I can write here CH4 as it is, right? And I have to calculate for this carbon, so I'll be writing there X, and hydrogen I already know that its oxidation state is water +1, okay, and the total algebraic sum of this molecule is taken as water 0. So what I can write here, X plus 1 into 4 times, so it becomes what, +4 equal to what, 0. Now I have to calculate for X, so therefore X is equal to what, -4. So the oxidation state of carbon in methane is what, -4, okay, and the hydrogen will become what, +1 here. Is it clear, students? Right? But we should remember the total oxidation number of this whole molecule, that will be also equal to what, 0, right? Because here 1 into 4, it becomes what, +4, +4 and -4 both get cancelled, and it becomes what, 0, right? So let me take now the second example, that is HSO4 minus, bisulfite anion. So I'll be writing here bisulfite anion, that is HSO4 and water negative charge, right? So I have to calculate for sulfur, so I'll be writing here X, right? Hydrogen will be water +1 and oxygen will be water -2, right? So +1 I'll be writing as usual, +1 plus X, that is that of sulfur, plus I'll be writing -2 into 4 times with respect to oxygen. So therefore -2 into 4, that becomes what, -8, and that will be equal to the charge, because that charge, that is what, -1 is here. So therefore I'll be writing here -1. I have to calculate for X now. X is equal to now -1, then I'll be writing here +8, and again I'll be writing here what, -1. and on simplification now x will be equal to what? Plus 6. So therefore the oxidation number of a sulfur in a bisulfite anion is what? Plus 6. Concept is clear, students? Similarly, we have to calculate for this nitrogen here in HNO3. So I'll be writing here HNO. How many times? 3 times. So to find it for what? X here, that is for nitrogen. Oxygen I know, that is what? -2. Hydrogen I know, that is what? +1. And I have to simplify 1 plus x plus 2 into -3, that becomes what? -6, right? And that will be equal to what? 0, right? So x have to calculate. X is equal to 6 minus 1 and x is equal to what? Plus 5. So therefore oxidation number or oxidation state of nitrogen in HNO3 is plus 5. Concept is clear, students? Now the next one is what? A sulfate anion, and we have to find the oxidation state of a sulfur in a sulfate anion. So I'll be writing here SO4 and that will be equal to what? -2, because the charge that has been already mentioned here, -2, right? And oxygen is what? -2, and I have to find it for sulfur, that is x plus 2 into 4, it becomes what? -8 equals to -2. Now x is equal to 8 minus 2. X is equal to what? Plus 6. So therefore oxidation state of sulfur in sulfate anion is plus 6. Now you are supposed to find the oxidation state of chromium in K2Cr2O7. K2Cr2O7 is called as a potassium dichromate, right? So I'll be writing here K2, then followed by Cr2, and then followed by O7. Oxygen I know, it is what? -2. Chromium I don't know, that will be what? X. Potassium I know, that will be what? +1. So therefore plus 1 into 2, okay, this plus 1 into 2, it becomes what? 2 plus x into 2, it becomes what? 2x plus -2 into 7, it becomes what? -14, and that is equal to what? 0. I have to calculate for what? This x. So therefore 2x is equal to 14 minus 2, and then 2x is equal to 14 minus 2, that will be what? 12, and here x is equal to 12 by 2, and x is equal to 2 ones and 2 6. So therefore x is equal to what? Plus 6. So now I can write oxidation state of chromium in potassium dichromate is plus 6. Is it clear, students? Thank you for watching this video, students. If you feel good, kindly like the video and subscribe to my channel. Thank you so much.